because this exact value situation is both difficult and not difficult at the same time, I've left a warm-up. So my advice to you is to try this, having already maybe done the exact values unit circle lesson and some work with it. Pause this, try them yourself, come back, see me work through the solutions, and then we are going to try to get through a lesson on finding exact values given a point. So this is not going to always generate unit circle measurements. This will generate fractions that are likely off the unit circle. So there's two ways to deal with exact values. One is on the unit circle, where you should be able to look at numbers and know they're on the unit circle because it's sitting right in front of you. And then there's also given a point. So try your hand at that, and I'll come back and lead you through it. So I'm going to pause just so you have a chance to pause. There, that's my pause. I'm going to move this stuff out of the way so that I don't know how much room it'll take, but I'll have ample room anyhow. So sine 60 degrees. Go to the unit circle. Find yourself 60 degrees. Find yourself sine. Remind yourself, hopefully, that this is alphabetical. So I need sine. Sine is the second one. Root 3 over 2 is the final answer. This one is to remind you, oh, didn't make it movable. This one is to remind you what to do with secant. So I'm not going to write it down like I did with the last one. I'm just going to pull off the answer the way I hope that you will pull off the answer. And that is, you're going to look up 45 degrees. You're going to look up cosine, and then you're going to flip it upside down. So 45 degrees, cosine is the first one, turn it upside down. And if you want to, you can times top and bottom by the same value. The one that isn't the one you want there, because the root in the bottom isn't fantastic. And you get yourself a final answer. C is another question that has a half problem. A half problem because although 210, like 45, is on the unit circle, cosecant, like secant, is not on the unit circle. So this time you're going to do exactly what we did the last time here, but you're going to look up sine for 210 and turn it upside down. So 210 sine, oh, this should be easy, negative 1 over 2, negative 1 over 2, negative 2 over 1 is the upside down, and make it look pretty, which is way easier than this one. All right, last question. Don't know how much room I'm going to use, so I'll put it here, and I have my scribble space. First up, 11 pi over 4, not on the unit circle, either in degrees or radians. My brain isn't working in radians today, so I'm choosing to convert it to degrees. So that's 45, 495, and I believe we did this actual radian to degrees before. 495 is not on the unit circle because 11 pi over 4 wasn't on the unit circle. But 135 is. Cotangent is not, so you need to dig out your quotient identity to replace it. and then find your values. Did we do this question? Practice isn't ever bad. No, we didn't. There's 135. It was cotangent, so I need cos on top, sine on the bottom, so the negative root 2 over 2 over positive root 2 over 2. Negative root 2 over 2 over positive root 2 over 2. Now I'm going to take a shortcut here. If you need to go through all the steps, they are in the unit circle video at the end. I am not going to turn this upside down and turn it into times. I'm not going to kill off the 2's and kill off the root 2's. I know that if I take a value and divide it by itself, I get 1, but there is a negative lingering around, so I get negative 1. The end of your warm-up. So I'm going to take a little pause, and we'll start up with this stuff. So in my pause, I set up a grid, because as soon as I see a point, I think, I better have a grid. Now I should be able to find this point pretty good. Positive 4, negative 4 puts me somewhere in this quadrant. And I'm going to draw myself a terminal arm to that point. And I'm going to turn it into a red terminal arm just so it stands out a little bit. So what we need to do is we need to draw a triangle using this terminal arm. And hopefully you recall that when we draw these little triangles, and here's my doodle, you always draw them to the x-axis, so you're creating your angles in the little bow tie. So that means when I complete this triangle, I'm going to draw it up to the x-axis, which I'm going to remain unlabeled just for fun. So some things I know about this triangle: it's right angled. Another thing I know about this triangle is I went 4 units in this direction and negative 4 units in this direction. And I have no idea what the hypotenuse is, and I need to know what the hypotenuse is. So I'm going to do Pythagorean theorem. So I'm looking for the hypotenuse. So I'm going to take the other 2 sides and square them and add them together. And the unfortunate part about this is an exact value question. So we have to have fractions and no decimals, so I can't write down the square root of 32, and I certainly can't take the square root of 32. So I'm going to have to do my reduced radical stuff from the very first lesson, quadratic formula. So I will explain this positive in a second, but I'm going to take it off. 32 is divisible by 16, which is a perfect square. So the hypotenuse is 4 root 2. And I'm going to plop that on the hypotenuse, and then I'm going to make you a little note to say, technically it should be plus minus, but hypotenuse is always positive every single time. So pause if you need to catch up there. Cosecant. Cosecant is the upside down of sine, so it's the reciprocal of sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. The angle is here, so this is opposite, this is adjacent, this is hypotenuse. So 4 root 2 for the hypotenuse over negative 4. And I am not allowed to leave that. The reason I'm not allowed to leave it is because all the fractions have to be in as reduced form as it possibly can be, which is not the case here. I can reduce that just a little bit, and actually I'm going to not squish it in. And I give you a little therefore statement. Therefore, cosecant theta is equal to negative root 2. So cosecant of this angle that we don't know what it is negative root 2. And we're not looking for theta, we're looking to find the cosecant of theta. So we're looking for the fraction. And if you're saying to yourself, this isn't a fraction, yeah it is, because it's negative root 2 over 1, and we're too lazy to write the 1. All right, next question, but I may come back to this one. Next question is to find all 3 primary trig ratios, so that's sine theta, cos theta, and tan theta, given the fact that I'm giving you the point negative 2, negative 8. So just like before, but not necessarily to scale, I'm going to move negative 2, negative 8. So definitely not to scale here. So draw myself a terminal arm. And join up to the x-axis. Technically, in the last question, although I did this, I should call this theta. That isn't something I would take off marks for. This is negative 2, this is negative 8. Again, I am looking for the hypotenuse, so I'm going to do that down here. So hypotenuse squared, remember hypotenuses, hypotenusae are always positive, so when I get my answer, I really don't need the plus minus sign, because the minus won't even apply. Okay, so is 68 reducible? Sorry, is root 68 reducible? Does 4 go in? Back to that long division. Yes, it does. 4 under a root times 17 under a root is pretty 2 ugly root 17. I probably shouldn't be that mean to numbers, but oh well. All right, so now let's do this. So I'm going to write everything down, pretending that maybe you've not remembered your grade 10 trig. So sine theta is opposite over hypotenuse. This is my angle, so this is opposite, this is hypotenuse, this is adjacent. So opposite over hypotenuse is negative 8 over 2 root 17. So it's negative 4 over root 17. Now, if you want to go through all the mumbo jumbo to get rid of the root in the denominator, you go right ahead. Remember that this is totally acceptable for me, except if you accidentally forget the theta, which is not allowed. You can't have sign of blank space. So you got to have something in there. But if you feel like going the extra mile This would be your alternate answer, which if you checked both decimals would be the same one. You're not allowed decimals. This is an exact value question. It says primary trig ratio, so unfortunately, we have to do cos as well. So cos is adjacent over hypotenuse, so negative 2 over 2 root 17. Above I did negative 8 divided by 2 is negative 4. Here I'm doing negative 2 divided by 2 is negative 1 over root 17. That is my cos theta ratio. Again, if you want to impress somebody, there's your impressive answer. And then last of all, tan theta is opposite over adjacent. So negative 8 over negative 2. Oh, relief. No roots. I can do that quite quickly. And the only problem is nobody can give an impressive answer because there's only one answer. So we have that. We have one last question. And you may be pre-whining with this. This isn't good, but it isn't as terrible as your imagination leads you to believe. So I'm going to take a little break because I have a hand cramp. I will be back and we'll take care of this. Maybe you want to start with your picture, and guess what? You're going to have to find the hypotenuse. So my break's happening now. Okay, I did a little bit of work during my pause, and that is I drew my triangle to the x-axis, so it's inside the bow tie. It's negative 9 on the x and 6 on the y, so I did a terrible job of scale. I said that it's a right angle triangle, so I can pull off opposite adjacent hypotenuse, and I put the theta there, even though a little dot or nothing at all would be fine. You're not really ever talking about this upper angle anyhow. What I didn't do is hypotenuse. So I'm going to do that now. And I hope you realize that it doesn't matter if you square the 6 or the negative 9 first, as long as you square both of them and add them together. So 117. Okay, so 117. Let's see if I can divide it by 9. Yep, I can. Remember, hypotenuse is always positive. That is obviously not the case with opposite and adjacent. So my hypotenuse is 3 root 13. If you need a refresher on this, be honest with yourself, be honest with me, do something about it, and get some help with it. All right, so if somebody ever asks you to find all 6 of them, which we're about to do right now, because it says all ratios, and they ask you to do them out of order, I suggest you put them in order, as in do sine first, cos second, tan third, then cosecant, then secant, then cotangent. It's a little bit easier, maybe. It's up to you in the end, as long as you finish all 6. So, first one, sine, theta. I'm not going to write opposite over hypotenuse. I'll just find the values. So, opposite over hypotenuse. That's 2 over root 13. Or 2 root 13 over 13, if you're looking for the impressive version. I am going to put a triple dot there because I need to come back to that line in a few minutes. Next one, cos theta. Cos theta, I'm not going to write adjacent over hypotenuse, but I'm going to pick adjacent over hypotenuse. I'm going to get myself a reduced answer. And then for those of you who want to impress people, there's this one. And then the last one of the bunch for the primary trig ratios is tan theta, which is opposite over adjacent, not writing that down, but definitely picking opposite over adjacent, and then making it look nice. Again, this one coincidentally has no alternate version. All right, so that's exactly what we did with the previous question. Except this question, I made it worse because I'm asking you for all ratios. So that means that I also, I'm going to leave it here because I've got my 3 triple dots. If I pick a color, I'm going to pick purple. I'm going to also have to find cosecant theta. I will also have to find secant theta, and I will also have to find cotangent theta. But that doesn't mean you start from scratch. That means with sine, you pick whichever of these you want to and you turn it upside down, because cosecant is the reciprocal or the upside down. Now I'm going to choose this one. Anybody know why? It's because it's the cool version with no root on the bottom. Cotangent and secant are upside downs of each other. I'm going to pick that one. And tangent and cotangent are upside downs of each other. No decision there. So really, all the work happens in the first 3, and you just flip for the second 3. So that is exact values in quadrants. Something I do want to remind you of is, and I'm going to use the unit circle because I've got all 4 quadrants. I'm hoping that in grade 11 you learned something called the cast rule, and I'll go over it in the history lesson as well. The cast rule is that in this quadrant, cos is positive. In this quadrant, all things are positive. In this quadrant, sine is positive, and in this quadrant, tan is positive. So it's called the cast rule because C-A-S-T. It's also called all students take calculus, but that's not true. So how about all students take civics? All students take careers. Either way, this is how it's set up. Basically, that means that sine is negative here, tan is negative here. Nothing's negative in this one. Sine is positive, so that's cos is negative here, tan is negative here. And in this one, sine will be negative, cos will be negative because tan is positive. This also, for example, means that secant is positive, cosecant is negative, cotangent is negative, and it works that way through all 4 quadrants. And like I said, I'll go over it a little more detailed and a little more clearly in the history lesson because I'll have some extra time for you to sit. Plus, really, this is a review. The reason I want to draw your attention to this scribbling is if I am in quadrant 1, 2, 3, 4, that means cos and secant should be positive, but everything else is negative. So when I asked you to do this question, and I asked you for cosecant, which is linked to sine, it was no doubt that it was going to be negative. Because it says right here, sine and its equivalent is negative. When I did this question, and I put you in quadrant 1, 2, 3, in quadrant 3, I'm expecting tan to be positive, or cotangent to be positive, and everything else to be negative. So what happened here? Tan was the only one that was positive as an answer. Cos was negative. Sine theta was negative. This was no surprise. And in the last one, it's quadrant 2 that I put you in. Quadrant 2, says that sine is positive and the other two are negative. Yep, sine ended up positive, cos ended up negative, tan ended up negative, which means when you flipped there was no sign change, and sine's partner cosecant was positive, cos's partner secant was negative, and tan's partner cotangent was negative. So the cast rule is not wrong. It's 100% correct, and you can keep that in the back of your mind when you're checking answers. So that is the end of the exact values quadrants note. Next up, I'm going to do the history lesson.